Happy Thursday, Kings and Queens. It's finally October 1st. Today we're going to jump into Math 7, Unit 1, Lesson 5a. We're going to be working on page 10 of your Math 7 Spiral Notebook. So let's make sure that we label it page 10 and also date it October 1st, 2020 at the top. As normal, our classroom norms are that your cameras are to be on, your mic should be muted when you're not speaking, and that you are ready to learn and chat. Of course, if there are any moments during this video where you need us to pause or slow down a little bit, just make sure that you type it in the chat so that you can get everything that you need in your notes or ask the questions as possible. For your materials today, you're only going to need your spiral notebook and your pencil. There is no student companion in Google Classroom today, so most of your work will go into your notes. So today we're going to be comparing proportional and non-proportional relationships. So we're going to always ask ourselves today, are the values in the table proportional? So as you can see in this image, we're going to look to see if we have consistent numbers in order to see whether or not something is proportional. So again, day one, comparing relationships with tables. So for today, we are going to have the following standard. Our standard for today is 7.rp.2, and our objectives are students will calculate and compare the quotients. Quotients we hopefully know means the answer to a division problem of the values in each row of a given table. We're going to generate a different recipe for lemonade and describe orally how it would taste in comparison to a given recipe, and then justify whether the values in a given table could or could not represent a proportional relationship. Our mathematical practices for today are MP6, which is attend to precision, and MP7, look for and make use of structure. So as always, we want to make sure that we take notes and then we work collaboratively. We're going to pause the video here momentarily so that you guys can copy down the standard and your objectives. Now let's jump into our engagement activity. And if you notice, the title says adjusting a recipe. So here's our recipe. A lemonade recipe calls for the juice of 5 lemons, 2 cups of water, and 2 teaspoons of honey. So that means for every 5 lemons that I use, I need 2 cups of water and 2 teaspoons of honey. So this is what you guys are going to do. You're going to invent 4 new versions of this recipe. One that would make more lemonade but taste the same. One that would make less lemonade but taste the same. One that would have a stronger lemon taste. And one that would have a weaker lemon taste. So I'm going to give you a hint for each one of these. The first one, if I want one that would make more lemonade but taste the same, maybe I could double or triple the recipe. For the second one that would make less lemonade but taste the same, maybe I would use less than 5 lemons. But if I do that, I would also have to figure out how many cups of water I would need or how many teaspoons of honey I would need. For the third one that would have a stronger lemon taste, maybe I just want to change the amount of lemons that I use, but not the rest of the recipe. And then one that would have a weaker lemon taste, maybe I would use less lemons and not change the rest of the recipe. So let's pause here, and in your journals, I want you guys to come up with 4 new versions of the recipe, and then we'll come back together so that we can share. Now that we've had some time to invent our 4 new versions of the recipe, I would love for one of you to unmute yourselves and share what you got for one of the options. So let's get a total of 4 students to share out what one of their recipes were, and then I'll give you which ones I came up with. So thank you guys so much for sharing. I want to be able to tell you what my lemonade recipes were. So again, just so you have for reference, the recipe had 5 lemons, 2 cups of honey, and 2 teaspoons of 2 cups of water, excuse me, and 2 teaspoons of honey. So for my first one where I wanted more lemon but same taste, for more lemon and same taste, I used 10 lemons, 4 cups of water, and 4 tablespoons of honey. So all I did was double my recipe. I used 10 lemons, 4 cups of water, and 4 teaspoons of honey. Now, for the second one where I wanted less lemons but the same taste, so I just wanted a smaller recipe, I took half of everything. So I used 2.5 lemons or 2.5, 1 cup of water, and 1 teaspoon of honey. For the third one where I wanted a stronger lemon taste, but I didn't change the rest of the recipe, I just said let's use 8 lemons and then keep 2 cups of water and 2 teaspoons of honey. And then for the last one where I said I wanted a weaker lemon taste, I said let's use 2 lemons, 2 cups of water, and 2 teaspoons of honey. So hopefully you understood how to make a recipe that was the same, but also alter it so that it would taste different. So here's our goal for today. Our main goal is we want to be able to decide if a relationship represented by a table could be proportional and when it's definitely not proportional. So let's take some time to explore how proportional relationships are different from other relationships. So let's jump into our first activity. We're going to talk about visiting the state park. So many of you may have gone to Watkins Park, which is in the county. So the entrance to Watkins Park costs $6 per vehicle. Additionally, each visitor must pay $2. So, what do you think the question is going to be? So let's take about 5 minutes of quiet work time and think about what the question is going to be, and then see if you can answer that question. And then we're going to discuss it as a class. So we're going to pause the video here just for you to think what question is Mr. Walker going to ask? And if you know what the question is, what is going to be the answer to that question? So obviously we want to know how much would each group pay. So now that we have a bearing on how much it costs for each vehicle and then each person, I want us to then again figure out how much would it cost for group 1 and then how much it would cost for group 2. Remember that each car it's $6 per vehicle and then each visitor must pay $2. So let's pause the video here and let's see what the total cost would be for group 1 and group 2. Okay, so hopefully you guys realize for group 1 that it would cost a total of $14. Remember, the car costs $6, and because there are 4 people in the car, each person must pay $2, which means it will cost $8 for the people inside, and 8 plus 6 will give you 14. And then for group 2, it's going to cost $20. Since there are 2 cars, that means it's going to be a total of $12. And then there are still 4 people each in each car. So $12 plus, again, 8 is going to give you a total of 20. So how might you determine the entrance cost for a bus with 50 people? Is this relationship proportional? Why or why not? So let's first write this table down into your notes and then let's complete the table and then we'll have a little bit of a discussion. So to complete the table, if I have 2 people in one vehicle, the total cost would be $10. If I have 4 people in one vehicle, the total entrance fee would be $14. And then if I had 10 people in one vehicle, which would be a pretty large vehicle, it would cost $26. So if we notice with 2 people, it's $5. With 4 people, it was 14, and then 10, it would be 26. Now, for 50 people, it would be a total of $106. Remember, it still costs 6 for every vehicle plus $2 for each person. So if there's 50 people, if we multiply that by 2, we get 100, and then $6 for the bus. So it will be a total of $106. Now, I want us to pause the video here, and in the chat, I want you guys to tell me whether this is proportional or not proportional. So, to answer the question that I just asked, this is not proportional. So, if you think about it, if I consider the ratio of people in the vehicle to the entrance cost, there are no equivalent ratios. Remember, the cost per person is not the same for different number of people. So each number of people and corresponding totals cannot be the same unit rate. So again, if I compare each one of these, it costs a different amount. So this is not proportional. So now let's jump into the next part. Now we're running laps. We want to be able to complete the table and check for proportionality. So let's look at Hans' run. It gives us the distance in laps in the first column, and then the time in minutes. Now, if you look at the third column, it asks us to find the minutes per lap. So that means that I want to take the second column and divide it by the first column to figure out what the minutes per lap are. So for instance, for this first one, I would do 4 divided by 2. And if I simplify that, that equals 2. So that means it would be 2 minutes per lap. So let's pause the video here and see if we can figure out what the rest of the table is going to equal. So once again, let's check what we get for Han. The first row, when we had 2 laps and 4 minutes, when I divided 4 divided by 2, I got 2. For this second row, when I do 9 minutes for 4 laps and divide it, I would get 2.25. When I did 15 divided by 6, I get 2.5. And then when I got 23 divided by 8, I got 2.875. So hopefully you noticed that all of these numbers, when I did try to find what the rate was of minutes per lap by dividing the second column by the first, all of these numbers were not the same. And because they were not the same when I found the quotient, like we talked about in today's goals, it is not proportional. So now let's check to see if Claire's run is going to be proportional. So we're going to do the same thing. The first column gives me the distance, the second one gives me the time, and I want to find the minutes per lap. So all I want to do is take the second column and divide it by the first column. For instance, I'm going to do 5 divided by 2. So let's pause here and see what you find. Okay, so now that we had some time to do the math for this second table for Claire's run, hopefully we noticed when we did 5 divided by 2, we got 2.5. When I did 10 divided by 4, we also got 2.5. If I did 15 divided by 6, I got 2.5. And then 20 divided by 8, I got 2.5. So what do you notice? Hopefully you notice that all of these rates are the same. And because these rates are the same, that means that the table is proportional. So that also means that the constant of proportionality, or your unit rate, is going to be 2.5. You might be asking yourself, what does this represent in the context? This just means that it takes Claire 2.5 or 2.5 minutes per lap. So again, because all of these numbers were the same when we found the quotient of each row of our table, that means that the table is proportional. So let's look at our next activity. We're going to talk about apples and pizza. So now we're going to do the same thing that we just did, except there's no third column because that's going to be your responsibility to find. It says, do the table show proportional relationships? So again, all I'm going to do is take my second column and divide it by my first column. And I'm going to see if my quotient gives me the same answer. If it does, it's proportional. If it does not, that means it's not proportional. So let's pause here, and then we're going to, for the first table, take the cost of apples and divide it by the pounds. And then for the second table, we're going to take the cost of the pizza and divide it by the number of toppings. We'll come back together in about 3 minutes to determine whether or not these tables are proportional. So let's start with the first table for apples. I want you guys to tell me in the chat, yes, this is proportional, or no, this is proportional. So let's take 30 seconds in the chat right now. Let me know, is this proportional or not? Okay, so hopefully you realize that yes, this one is proportional because the cost per pound of apples. So when I divided $3.76 by two, $5.64 by three, and so forth, hopefully you know that in each row it was $1.88 per pound. The number that I got when I divided for each row was $1.88. So yes, this was proportional. Okay. Now let's look at the second table. Remember, I had to divide the second column by the first column. $11.99 by 2, $13.49 by 3, $14.99 by 4, and $16.49 divided by 5. In the chat, once again, let's take 30 seconds. Tell me if this is proportional or not proportional. Okay, so now that our answers are in, hopefully you realize that no, this was not proportional because the cost per topping is not the same in each row. When I divided each one of them, I got different numbers. And of course, you could have used a calculator for this because these numbers are kind of difficult to divide in your head. But again, the second table is not proportional. So now it's asking me, write the equations for the table that shows the proportional relationship. So the only one that shows a proportional relationship was the first table. Now, hopefully you should have realized what the constant of proportionality was. So what is the constant of proportionality? Hopefully you realized that when we divided each one of them, we got the same number, and that was your constant of proportionality, which was $1.88. So your equation for this would be, again, you're going to start with the second column. We'll say C for cost of apples equals $1.88 times P for pounds of apples. So your equation would be C equals 1.88 P. And that just means for every pound that we have, we're going to multiply it by $1.88 to find out what the total cost is. So again, to find the total cost, C, it's equal to 1.88p. Or if you wrote it in the form of y equals kx, it would be y equals 1.88k, or 1.88x, excuse me. So let's do some recapping. We examined multiple ways a table could represent a proportional relationship. So let's answer these questions. What is the constant of proportionality represented in the running laps table? Remember, that was one of our first activity. So we noticed that, well, somebody share out what that constant of proportionality represented in that table. We also want to know, how do you determine if the values from a table represent a proportional relationship. So we know if the quotient is the same in each row, the table could represent a proportional relationship. So remember, quotient meaning if I divide the second column by the first column, if I get the same number, then that means that it's a proportional relationship. It can be helpful to compute and write down the quotient for each row if necessary. And how do you know if the relationship is not proportional? Remember, if all of the quotients are not the same, meaning when I divide it, it's not a proportional relationship if all of my answers come out to be a different number. So, once again, here's my vocabulary word wall. Again, we talked about constants of proportionality again, and we've also talked about quotients in a table. So, if you notice in this portion, when I found the constant of proportionality for each one of these, they were the same, which means these represent proportional relationships. So, for the sake of time, we're going to skip over this one just for the sake of time. And let's go over our goals for today. Once again, our goal for today was to decide if a relationship represented by a table could be proportional and when it's definitely not proportional, which we were able to do. So, for our closure for today, really quickly, because I wanted to make sure that you guys have time, if you have not submitted your quiz from that was due yesterday, you have until 3:30 today to do so. It will be marked a little bit late because obviously you had 2 days to do the quiz, but I wanted to give everybody the extra opportunity to complete that specifically because the progress report window is open. So, Mr. Walker is currently working on grading many of your assignments and Mr. Spencer is putting them into School Max. So you should be monitoring your grades. For those of you that are not completing assignments, it's going to be evident when you look at your grade report on SchoolMax. Again, progress reports come out officially on the close for progress report window is on Monday. So it's important that you're completing your assignments. This quiz grade is an assessment grade. Therefore, I wanted to make sure that you had enough time to complete it if you have not. So at this time, we're going to end our live class session today. And if you have not completed that quiz, please make sure that you do so. If you've done the quiz already, then you do not have an independent assignment for tomorrow or for today, excuse me. So we will meet tomorrow, Friday, for our live class session and keep moving. Otherwise, have a great rest of your day.